So here we are in part 6 of the substitutions and eliminations. We're really into the review of all of the 2 chapters that are leading up to test 3 here. When we look at this page, we see 4 reactions, and what do you know? There were 4 reactions in this section. There's the SN2, there's the SN1, there's the E2, and there's the E1 mechanism. So when we look at these, we need to think about what we've talked about over the past few videos for how we decide what can happen with each one. When we look at the first two, A and B, we see that we have the same starting material in both. It's a primary iodide. So they're going to be the 2 mechanisms because it's primary. So the first one has a strong base, good nucleophile. So it's going to be the SN2, whereas the second one has a strong base, weak nucleophile, so it's going to be the E2. So in the substitution where we draw the mechanism, in the SN2, the nucleophile comes in, displaces the leaving group, and we get this as our product along with the iodide, which we don't worry about. In the second one, we said it was an E2, so we need to look for a hydrogen on the adjacent carbon. Our strong base weak nucleophile, T-butoxide, will grab the hydrogen, form the double bond, kick out the leaving group. So we get our 1-pentene, we get T-butanol, and we get the I-. Okay, in the second 2, since we've used the 2 mechanisms, the second 2 on the page have to be the 1 mechanism. So how do we decide which one's going to be the SN1 and which one's going to be the E1? We see that the starting materials are exactly the same. In the fourth one, we have a small molecule as our solvent. In the third one, we have a very large T-butanol. We also see in the third one we have heat. And remember what we learned about heat. Heat forces it to do an elimination. So this is going to be an elimination since we have a large weak base, weak nucleophile. It's going to have to go for a hydrogen on the outside edge of the molecule. And so our main product will be this. So we're going to form the cation, and then T-butanol will grab a hydrogen on the outside edge to form the alkene. If we had methanol in heat, we would get the double bond going to the more substituted side instead. If we had just methanol, we would go for a hydrogen over here when we did the elimination, but we don't have methanol, we have T-butanol, so we go for the less substituted hydrogen. In the bottom one, we have the same first step where we form the cation, and then methanol adds to the cation to form our protonated ether. And then our second equivalent of methanol will grab the hydrogen off to form our desired product for the reaction. And those are the 4 mechanisms you have to know for test 3, SN1, SN2, E1, and E2, and look back at the pages that talk about how you decide what can happen with each. So here we have some mechanisms to draw. In the first one, we have a strong base, we have a primary leaving group, so it has to be an SN2 mechanism. So our nucleophile is just going to come displace the leaving group, and it's done. We don't have to draw anything else. In the next one, we see that we have a tertiary leaving group and a weak base, weak nucleophile. So it's going to have to be, since it forms a substitution product, an SN1. So our leaving group leaves, forming the cation, and then the methanol will add to the cation to give us our protonated ether. And then another equivalent of methanol will come in and grab the extra hydrogen to form the neutral methyl ether. And then the last one, we see a strong base, we see heat, we see a very sterically hindered strong base. So this is going to have to be an E2. And so the strong base is going to grab a hydrogen on the adjacent carbon, form the double bond, kick out the leaving group, all in one step, and we're done. So here are some reactions. Predict the products for them and see what can happen. In the first one, the CH3 minus is a strong base. So the first part of this, it's going to pull the hydrogen off of the phenol to form the phenoxide ion. And then the phenoxide ion will react with the propyl bromide in an SN2 to form the propyl phenyl ether. In the second one, so the first step is an acid base, and then the second step is an SN2. In the next one, it's going to be an SN2 mechanism where the iodide comes in, kicks off the bromide, and we get the iodocyclohexane. In the third one, it's going to be an SN1 because we have a good nucleophile. It's on a tertiary carbon. We have a weak base, weak nucleophile. So we're going to kick out the bromine to form the cation, and then methanol will add to the cation to form the protonated ether, and then another equivalent of methanol will remove that extra hydrogen to get to our protonated, or to our product, the ether. The next one, sodium cyanide, ignore the sodium, it doesn't matter, is a good nucleophile, so it's just going to be an SN2. And 1, 2, 3, 4, 5, 6. Got to make sure we have the right number of carbons and add the cyanide on in place of it. The next one, we have the primary leaving group and the very bulky base, so it's going to be an E2. And it's going to grab the hydrogen, form the double bond, kick off the leaving group, and we get the alkene. And then the last one, since we have heat, it's going to be an elimination. We have a tertiary leaving group and a weak base, weak nucleophile, so it has to be an E1 elimination. So the leaving group leaves, forming the cation, and then our methanol will grab the hydrogen off of it, forming the product. So make sure you look back at how do we decide what type of reaction it will be. Think about what happens in the overall reactions and go from there. And if you have any questions, remember, send me an email. So on this page we have some problems where we need to give the necessary reagents to accomplish the following transformations. In the first one, we have the aniline that needs to go to the negative charge on the nitrogen, so we have to add a strong base. So we could go to a CH3 minus. It would remove the hydrogen off of that to give us the negative charge on the nitrogen along with methane, which would bubble out of solution. And then we see the negative charge on the nitrogen. We need to form a nitrogen carbon bond to a primary carbon, so we need to do an SN2 after our acid base reaction. And then the NH2 minus will just come in and displace the bromide to give us our product. And the second one, the best way to control what happens in a reaction is to do a 2 mechanism. Don't leave it to a 1. So this needs to be an E2. So we need a big bulky base to do the E2. So T-butoxide, grab the hydrogen, form the double bond, kick off the leaving group, and we're done with our reaction. And the last one, we see that the number of carbons is different again. Like in the first one, we had to form a carbon-nitrogen bond. Here we need to form a carbon-carbon bond where the 5 carbons of our 1-bromopentane end up getting extended with 3 more carbons where we have the acetylide that we have to form a bond to that primary carbon that had the bromine. So this needs to be our nucleophile. This carbon of our acetylene has to come from our nucleophile, so it has to be a CH3 minus, or a C of the acetylide with a negative charge on it to displace the primary bromide to give us our product. So here we are on the last page of part 6 for the substitutions and eliminations, and we see 4 reactions on the page. So we know that we have 4 reactions with different mechanisms that we need to know for this test. So the odds are each one of these is a separate mechanism, just like on the test. There will be 4 mechanisms that you have to draw, and one of them is going to be an SN2, one will be an SN1, one will be an E1, and one will be an E2, and we have to decide what can happen in each of them. In the first 2, we see a weak leaving group with a strong acid on a tertiary carbon, so these first 2 have to be some sort of 1 mechanism. The second 2, we see a secondary carbon with a good leaving group and a strong base, strong nucleophile, or a strong base, weak nucleophile in the last one. So these are going to have to be 2 mechanisms. So then we have to look at how do we decide what type it is. In the first one, we have no heat. In the second one, we have heat. So the second one's probably an E1. The first one's going to be an SN1. In the third one and the fourth one, we see the strong base that can't act as a nucleophile. So it's going to be the E2, and the small one that is a good nucleophile, good base, will be the SN2. So then we just have to draw our mechanisms to make sure they all go for what we just said they need to be. So for the SN2, the nucleophile comes in, the leaving group leaves, all in one step, you're all done. For the E2, the base comes in, forms a double bond, kicks off the leaving group, and you're done. Okay, those 2 are the really easy ones. You don't have to draw anything else. You just show that and you're done. Then in the first 2, we have to protonate our alcohol to make it a good leaving group. It has to leave, forming the cation. And then in the top one, the bromide adds to that cation to give us our product. And the second one, we know we need to get to the elimination product. So the first step is we protonate our alcohol just like we did in the first one. So we get the positive charge on there. It leaves, forming our cation. And then from this cation, we have our water come in, our best base in solution, which is water is better than bromide, and it grabs the hydrogen, forming the double bond, giving us our product. So those are our 4 mechanisms and how we think about what can happen in each of them. So look at those as we're going along, as you're working problems in the back of the chapter. Try to decide how you're going to go about that, and look back in the beginning of video 5, which has the how do you decide what type of reaction it will be, and make sure you know what can happen in each of those.